Close your eyes for a moment and listen, not to music, not to narration, to this. What you are hearing is not a recording of thunder. It is not a sound effect produced in a studio. It is the actual electromagnetic voice of Jupiter, recorded by NASA's Juno spacecraft as it crossed the planet's magnetospheric boundary for the first time in 2016, converted from radio waves into audible sound so that human ears could process what the instruments detected. It sounds like screaming. It sounds like something enormous being torn open. It sounds in a way that is difficult to articulate without sounding unscientific, like warning. Juno's mission scientists described it in their published papers using careful technical language: intense plasma wave emissions, magnetospheric boundary crossing phenomena, electromagnetic chorus. But the engineers in the room, when the audio was first played back, used a different word. They said it sounded alive. And the deeper Juno flew into Jupiter's atmosphere, the more that description felt less like poetic license and more like the most accurate statement anyone had made about the largest planet in our solar system. Jupiter is the reason you exist, not metaphorically, not in the soft inspirational sense that the universe conspired to produce you, in the hard mechanical sense that without Jupiter sitting in its current orbital position, the inner solar system where Earth formed would have been bombarded by asteroid and comet impacts so frequent and so catastrophic that the chemistry required to produce life would have been interrupted before it could accumulate enough complexity to matter. Jupiter's gravitational field is so powerful that it captures or deflects a significant fraction of the debris that would otherwise reach the inner planets. It acts as a shield, a gravitational sweeper positioned at the outer boundary of the rocky planet zone, consuming or redirecting the projectiles that the early solar system threw toward the sun in enormous quantities. Every astronomer who has modeled the evolution of our solar system arrives at the same conclusion. Without Jupiter in precisely the position it occupies, Earth is a very different place, possibly no place at all. The planet that gave us our existence did so not by providing anything directly, but by standing between us and everything that would have prevented life from taking hold. It protected us. For 4.5 billion years it has protected us. And the question that the Juno mission's deepest data has now forced into the scientific conversation, the question that nobody at a press conference has asked directly, but that a growing number of researchers are asking in private correspondence and in the careful language of peer-reviewed papers, is this: is Jupiter protecting us from what is outside the solar system, or is it keeping something inside from getting out? To understand why that question is no longer as absurd as it sounds, you need to understand what Jupiter actually is at the level of its deep structure, and more specifically, what it is not. The standard model of Jupiter describes it as a gas giant, a planet formed from the same solar nebula as Earth and the other planets, but in a region of the early solar system cold enough that volatile gases could condense and be captured by the growing planetary body's gravity. In this model, Jupiter is essentially a very large ball of hydrogen and helium, with a rocky or icy core at its center, its interior organized into layers of gas that become progressively denser and hotter with depth, until near the center the pressure is high enough to force hydrogen into a state called metallic hydrogen, a bizarre form of matter in which the electrons are stripped from their atomic nuclei and flow freely through the bulk of the material, like electrons flow through a conductor, giving the interior of Jupiter the electromagnetic properties of a metal, despite being composed entirely of the simplest element in the periodic table. This is the standard model. It is well supported by decades of remote observation, and the Juno mission was designed in significant part to confirm and refine it by measuring Jupiter's gravitational field with extraordinary precision as the spacecraft made its repeated low-altitude passes over the planet. What Juno's gravitational harmonics measurements revealed when they were first analyzed was not the confirmation the models predicted. The gravitational field of a planet encodes information about how its mass is distributed internally. By measuring tiny variations in the gravitational pull that Juno experienced at different points in its orbit, the mission team could reconstruct a picture of the density distribution inside the planet without ever sending a probe below the cloud tops. What the gravitational harmonics showed was a core that was fundamentally different
different from the compact, dense, rocky or icy core the Standard Model predicted. Instead of a well-defined, concentrated mass at the center, the data showed what the researchers described in their published analysis as a diffuse, dilute core, a central region where the density distribution was not what you would expect from a solid or semi-solid planetary core, but from something far less concentrated, spread across a volume much larger than any standard formation model accounted for, with properties that suggested the core material had been mixed or dispersed into the surrounding metallic hydrogen layer in a way that could not have happened during normal planetary formation. The core was not a rock, it was not a solid, it was a void dressed in the mathematics of mass distribution, a structured absence at the center of the largest planet in our solar system, occupying a space so vast that the entire Earth could fit inside it with room to spare, with a gravitational signature that said something was there without being able to say what. The Great Red Spot has been visible on Jupiter's surface for at least 350 years, possibly longer. It is the oldest continuously observed weather phenomenon in the solar system, a storm wider than the entire Earth, with wind speeds exceeding 400 miles per hour at its outer edges, rotating counterclockwise in Jupiter's southern hemisphere in a perpetual anticyclonic motion that should, according to the fluid dynamics of planetary atmospheres, have dissipated centuries ago. Storms on Jupiter are powered by the heat rising from the planet's interior. Jupiter radiates significantly more heat than it receives from the sun, which means the planet has an internal heat source, a reservoir of thermal energy left over from its formation that continues to power its atmospheric dynamics billions of years after the planet formed. By the Standard Model, this excess heat should be declining as the planet slowly cools over geological timescales, but it is not declining. Jupiter's heat output has remained essentially constant across all the decades of measurement. Something inside the planet is maintaining the thermal output. Something is keeping the heat flowing upward at the same rate it has always flowed, sustaining the atmospheric dynamics, including the Great Red Spot, against the dissipative forces that should have ended that storm long before any human eye observed it. The Standard Model has no mechanism for this. The metallic hydrogen interior is electrically conductive, but not a heat source. The diffuse dilute core is not a radioactive heat generator, and yet the heat keeps coming, constant, regulated, from the interior of a planet whose core is not what it should be, sustaining a storm that should not still exist at a rate that does not change as the planet ages. Not a storm, an energy exhaust, a regulated release of energy from an interior that is maintaining its output with a consistency that natural cooling processes do not produce, a planet that functions less like a ball of gas and more like a machine that has been running for 4.5 billion years and shows no sign of stopping. The mythology of every ancient civilization that developed sophisticated astronomy contains versions of the same figure, a vast entity associated with the sky, with power, with something that existed before the current order of the cosmos was established. The Greeks called them titans, the entities that preceded the gods, older than Olympus, associated with forces that the gods themselves feared and worked to contain. In the mythological tradition, the titans were not destroyed. They were imprisoned, placed behind a boundary, confined to a space from which they could not escape, their power contained but not eliminated. The Greek word for this containment is Tartarus, not hell, not death, a place of confinement for something too powerful to be destroyed and too dangerous to be left free. In ancient Mesopotamia, in the cuneiform tablets that predate the Greek and Roman mythological traditions by thousands of years, there is a recurring phrase associated with the great planetary gods, a warning embedded in the ritual language of the astronomical priests who tracked the movements of the planets and interpreted their positions as messages from the divine order. The phrase translates differently depending on the scholar and the specific tablet, but the core meaning is consistent across all versions. Do not awaken what sleeps in the deep place. The deep place in Mesopotamian cosmological language was not the underworld. It was not a metaphor for death or the unconscious. It was a specific location, a place of confinement, a place where something ancient had been placed beyond the reach of the ordered world, behind a...
There is a sound that every human being born in the last 100 years has heard at least once. A steady, rhythmic beep in a quiet room. A heart monitor. The sound of a life being measured in intervals. The sound of something that could stop at any moment. Hold that sound in your mind for a moment, because the universe makes a very similar sound. Not audible to human ears, not detectable by any instrument you could hold in your hand, but present, measurable. A pulse, a rhythm in the distribution of matter across the observable cosmos that has no satisfying natural explanation inside the current framework of physics. Scientists have been measuring it for decades, and the closer they look at it, the more it resembles something that should not be there. Something organized, something that pulses with a regularity that random gravitational processes do not produce. Something at the edge of everything we can observe that appears in the data to be looking back. For 50 years, Voyager 2 has been traveling through the dark, a machine the size of a small car, built with 1970s technology, carrying instruments designed by engineers who did their calculations by hand, broadcasting a signal into the void at the speed of light and waiting for something to answer. Nothing has answered. The silence has been total, absolute, and in a very specific scientific sense, deeply strange. Because the silence is not uniform. The universe should be the same in every direction. The cosmological principle, the foundation of modern physics, states that at large enough scales, the cosmos is isotropic, meaning identical regardless of which direction you look. But the data coming back from our deepest observations does not show a uniform silence. It shows a silence with a direction. A silence that is louder in some places than others, a void that is not empty but oriented. And at the center of that orientation, at the coordinate toward which the data has been pointing for 30 years, sits something that physicists named with a phrase that is either the most accurate description in the history of science or the most terrifying. They called it the Great Attractor. The Great Attractor is not a star. It is not a black hole or a galaxy cluster or any conventional astronomical object that fits neatly into the catalog of known things. It is a gravitational anomaly, a region of space toward which everything in our local universe appears to be moving. Not just our galaxy, not just our local group of galaxies. Hundreds of thousands of galaxies spread across a volume of space, hundreds of millions of light years across, all of them moving together in the same direction, all of them being drawn toward the same coordinate, as if the universe itself has a drain and we are in the water circling it. At the velocities involved, the motion cannot be explained by any concentration of visible matter in that direction. The galaxies that can be observed near the attractor do not contain nearly enough mass to generate the gravitational pull required to move what is being moved. Something else is there. Something massive, something that does not emit or reflect light in any wavelength we have learned to detect, something that makes itself known only through its gravitational influence on everything around it, pulling with a force that operates across scales so large they challenge the imagination. And it is in the direction of the Great Attractor that the anomaly NASA's instruments detected points. An anomaly that the agency's own researchers struggled for years to find language adequate to describe. The work began with a researcher named Alexander Kashlinsky. Working at NASA's Goddard Space Flight Center, Kashlinsky and his team spent years analyzing the motion of galaxy clusters across a large region of the observable sky. They were looking for something called bulk flow,
the large-scale, coherent motion of galaxy clusters relative to the cosmic microwave background, the oldest light in the universe that fills the sky in every direction as a faint remnant of the Big Bang. What they found was something they initially assumed was a measurement error. Hundreds of galaxy clusters spread across an enormous volume of space, all moving together toward the same region of sky at velocities that could not be explained by any known gravitational source within the observable universe. They called it dark flow. The term was precise and deliberately understated. The motion was dark because its source was invisible. It was flow because the movement was coherent, organized, directional, like water moving through a landscape shaped by forces you cannot see, but whose effects you can measure precisely. The Kashlinski anomaly, as it came to be known in the literature, pointed in the same direction as the Great Attractor, and the data suggested that whatever was generating the pull was not inside the observable universe at all. It was outside it, beyond the cosmic horizon, in the region of space from which no light has had time to reach us since the Big Bang, in the darkness beyond the edge of everything we can see. Modern theoretical physics has a framework for thinking about what might exist beyond the observable boundary. It is called brane cosmology, and it emerges from string theory's requirement that the universe has more dimensions than the four we can experience. In this framework, our universe is not the totality of reality, but a membrane, a brane, a four-dimensional surface embedded in a higher dimensional space called the bulk. Other branes may exist in the bulk, other universes, parallel membranes floating in higher dimensional space, separated from ours not by distance in any direction we can move, but by displacement in a dimension we cannot access. The gravitational force, unlike every other fundamental force, is not confined to our brane. It leaks into the bulk. It can reach across the higher dimensional gap between branes and exert influence on our universe from outside it. Dark flow in this theoretical framework is not a mystery, it is an explanation. It is the gravitational signature of another brane, another universe, pulling on ours from the outside, pulling with a force that crosses dimensions we cannot enter and originates from a source we cannot observe. What Kashlinski measured in this reading of the physics is the gravitational handshake between two universes, the tremor in our cosmic membrane caused by something pressing on it from the other side. When the James Webb Space Telescope turned its mirrors toward the coordinate of the Great Attractor, the expectation in the scientific community was that it would see nothing conclusive. The attractor is in a direction heavily obscured by the plane of our own galaxy, a region called the zone of avoidance, where the dust and stars of the Milky Way make deep observation difficult. What Webb saw through that obscuration when the data was processed and analyzed and the galactic foreground was carefully subtracted was not what the models predicted. The models predicted diffuse, large-scale structure, random distribution of matter at the extreme limit of observability. What the processed data revealed was structure, not the chaotic structure of random gravitational clustering, organized structure, geometric, repeating, patterns in the distribution of matter at the cosmic horizon that had no natural explanation inside a universe governed by random quantum fluctuations and simple gravitational attraction. Patterns that looked in the language one researcher used in a paper that circulated briefly before being revised for resubmission, less like the edge of a universe and more like the interior surface of something, less like a boundary and more like a wall. And in one region of the processed data, at a scale and distance that put it at the very limit of Webb's observation reach, a configuration of matter that caused the researcher who first isolated it to sit back from his monitor and not speak for several minutes. Not because it was conclusive, not because it was proof of anything, but because of what it resembled. In the data, at the edge of the observable universe, in the direction that everything is moving toward, there was something that looked back. Silence now. Complete silence. No narration, no music. Just the sound of space. The sound of nothing. Sit with this for a moment. because what comes next requires that you have felt the full weight of what has just been described. The universe is not empty. The silence is not random. Something is at the edge, and we are moving toward it. Stay with that. Let it settle, because the final question is not scientific. It is older than science, much older.